Hello, my dear lions. Good evening, Soumya, Chinmay, Harboran. Good evening, my dear lovely warriors, to this next amazing part of Newton's laws and friction in your road series for all the JEE aspirants, right from the zero level, right from the basics to the mains and the advanced level for all the JEE mains and advanced aspirants. So this is a road series which is going on YouTube on the one and only, the number one JEE English channel in the country, which is the Vedantu JEE English. And this is none other than your Captain Shreyas, your physics master teacher, your guiding force, your mentor, your torch, your light for your road towards JEE. And if you are not yet a part of this channel, make sure you are a part of this, becoming a subscriber by hitting that subscribe button and hit that like button, because YouTube understands that you are then interested in JEE related, academic videos and strategies and everything else. So you are kept away from the distractions. Thank you so much, guys. I am hopefully live and audible to all of you. Hello, Dream One. Thank you for all the love from Tamil Nadu. Yes, Soumya, the live is going on right now. So let's begin with the class and let's do a quick recap of what we did last lecture. In the last lecture, we have seen Newton's first law of motion, which is a law of inertia, where the body maintains its state of whatever it is doing before. It continues doing so even later on. We have seen momentum, which is mass into velocity. Then the Newton's second law, where the sum of all the forces acting on a system gives you, the mass into the acceleration when the mass is constant. And then we have also seen the Newton's third law, for where every force you apply, which is an action, there is a reaction which is on the other body, but they don't cancel out each other. We have seen all of this. We have also seen the common forces in nature, starting off with weight, which is nothing but the gravitational force which acts downwards, which is mg. Then we have seen contact force, which is the electromagnetic repulsive force between the surfaces, whose resultant may come out at an angle. And there are two components of it. One along the surface, which is called friction, and the one along the perpendicular to the surface, which is called the normal. Together they make the contact force. And we have seen examples of normal force. We have then seen tension. Tension is the force which acts within the string, the intermolecular elongation which happens. And we have seen how the tension remains same throughout an ideal string and how to calculate the tension. Lastly, we have seen the spring force, which is kx. And I do not use the minus sign because the direction depends on what you are assuming, whether it is the spring or whether it is the block. So that's why magnitude is important. K is basically the spring constant. Lastly, we have seen what is the free body diagram, where you show all the forces acting on the body and then find out all the unknowns by showing all the forces and all the effects. And then we have solved a lot of problems on that. All right, that is what our last lecture was, including some pulley problems like this weighing machine problems, spring balance problems, right? And even we did frames of reference, inertial and non-inertial, and how a non-inertial observer who is accelerating cannot apply Newton's laws. So he takes the help of something called as the pseudo force, which acts opposite to the observer's acceleration. So if the observer is in a lift going up, the pseudo force acts down, which is a fake force. That means pseudo. Pseudo means not real, to just apply Newton's laws. Apart from the other forces that you have, you also add pseudo force and you then write it as mass into acceleration. Right? We have seen those lift questions and pseudo gravity questions, all of that. So now it's time for some friction related questions, block on block questions, angle of repose, all of that. And then we will also see, multiple pulley questions and, things like that, right? So let's begin. Soumya, let me tell you one thing, my dear kid. If at all you feel low, if at all you feel that you cannot do it, in fact, that is something which you should take it up as a challenge, because you cannot fall below that. I mean, the fear should come when you are doing well. Maybe I might not do well tomorrow. But when you are doing so bad, what worse can happen? The only good thing that can happen is you can rise. So make sure that whatever you do tomorrow is better than today, and whatever you do day after tomorrow is better than tomorrow. So you will see within a month, within a week, you will be at a next level. And you will be at a constant progress, which is what is needed. Consistency is needed. Slow growth is needed. You cannot expect a sudden rise. So gather yourself up and be in these live classes where we all have similar students who want to aspire and crack JEE, right? So let's begin with the class. Hello Ananya, nice to see all of you. Hello Smiling Gamer. Good evening, my dear warriors. For all the love, thank you so much. Let's begin. And I hope you guys have smashed the like button. Now, I just explained to you in the previous lecture that friction is basically the component of the contact force which is parallel to the surface. So, if you have anything, it could be anything guys, which is in contact with some kind of a surface over here. So, there could be some kind of a contact force here. That contact force will have two components, remember that. One component will be perpendicular, one component will be parallel to the surface. The component parallel to the surface is referred to as friction, whereas the one which is perpendicular to the surface is called normal. So this is nothing but our frictional force. Now whenever I think of friction, or you might think of friction, you might always think negatively. Friction is bad, friction is evil, friction is not needed. Why is it there? It is causing loss. It is going to, take away things from us. Thank you, Rajesh Khanna. Hello, Rishi. But that is not so. Without friction, you cannot hold this pen. I could not hold this pen. Imagine it would just slip out of my hand because there is no friction, nothing to stop it. I can't even put on my clothing. My shirt would have fallen off. You cannot even walk. You cannot do most of the things that you think. So friction is not all that bad. But yes, there are situations where you don't need friction. But that does not mean it is completely bad. Like when you are moving or some things are rolling, skidding, you don't want friction. You want, the battery power to save, or the petrol or the diesel to be saved. You want things to move indefinitely. When you give it a push, it should not stop. So that's where friction plays a spoil sport. But otherwise, friction is also going to do some useful things. Now this friction, all right, there are two kinds of friction that you see in nature, depending on whether these two surfaces are moving together, means there is no relative motion, versus there is relative motion. So when you have basically no relative motion between them, no relative motion between them, the friction that you encounter is basically called as static friction. Static friction. The symbol for that usually happens to be Fs. The symbol for that usually happens to be Fs. The other type of friction is when there is relative motion between the surfaces. When one surface moves relative to the other, such a friction, because there is motion, another word for that is kinetic. So that's why it is also called as kinetic friction. And the symbol for that usually happens to be Fk. K for kinetic, S for static. Usually you use small f symbol for friction. It's not hard and fast, but just the usual stuff. Yep. Completing the syllabus within October is better. If you have the option, Rishit, complete it before October. But if you don't have an option, just for the sake of completing, don't complete it. Take it, okay, at the right pace, but complete every detailed and concept and complete it by October. Okay. Thank you, Smile Abdul Rahman. Thank you so much. Thank you. Means a lot. Now, what are some examples of no relative motion versus relative motion? Okay, tell me one thing. I am walking on the road. When you walk on the road, do you encounter friction? Yes or no? Put it up in the chat box. Yes. You encounter friction? Correct. Now tell me, when you are walking on the road, the kind of friction that you get, is it static or kinetic? The kind of friction that you get, is it static or kinetic? Hi Joseph. Do you get static or kinetic friction? Come on, quickly put it up in the chat box, my dear warriors. Yes. Sir, why static friction is less? We'll come to that. Anjat will be coming to that in a bit. First, let's discuss the phenomena. Let's discuss the examples. Then let's come to the formulas. Let's see who is more, who is less. Yeah. So the kind of friction that you encounter is static in nature. You will be scratching your head. You will be like, what the hell, sir? I just thought it would be kinetic in nature. Yes. Some of you also said kinetic, but that's wrong. Let me tell you why. Because you might be moving, but the surface of your slipper with respect to the ground floor is not sliding. Once it falls, it is there. It's your leg which tilts. It's your leg which tilts. It might move from here to there or like this. Your leg might tilt, but your foot is on that floor over there until you lift it. Once you lift it, friction is gone and the foot falls at a new place and it is there. It is not sliding until you lift your foot again and then at a new place. So the friction is not kinetic, it is static. Thank you for all the love from Mizoram. The friction is static in nature. Very, very crucial. Many people get this wrong and I don't blame you for that. So the example for this, while you are walking, the feet encounter static friction. The walking feet encounter static friction. But have you seen kids walking? Have you seen those small kids, toddlers walking? They drag their feet, gizz, gizz, gizz. They have a lot of fun. They wear those nice floral or colorful shoes with maybe lights and music and God knows what. And then they rub their foot on the ground. Then there is relative motion. Hence, such a friction in that case is kinetic in nature. So a kid dragging his feet, the friction is 100% kinetic in nature. Is that right? Similarly, you apply the brakes, zoop, suddenly, what happens? The tires screech, they make marks on the road before it comes to a halt. That kind of friction is 100% kinetic in nature. So, imagine sudden braking of wheels. Sudden braking of wheels is 100% kinetic in nature. Yes, definitely. You rubbing your hands. Just try to rub your hands. Do you feel some heat? Do you see the relative motion is there between the surfaces? What is the friction? It is not static, it is kinetic in nature. So rubbing of hands is basically kinetic in nature. More examples of static friction. Imagine somebody is holding a box against a wall. Have you ever tried to hold something against the wall? Like something is there and you're just pushing it and it does not slip down. So the friction over there is static in nature. So an object held stationary against a surface, 100% it is static in nature. Have you ever stepped on an escalator or travelator, maybe at a mall or an airport, where there is a belt which keeps moving? There are motors, so that belt keeps moving. You might have seen the belt keeps moving like this, and on that the person is standing on it and the person goes from one place to the other. Yes, have you seen that? If you stand on it, what is pulling you forward? Dream 11, I think it might be 2 hours or so. Yep. There is friction in walking, Nikhil. Without friction, you cannot walk. Imagine you put your foot and it's slippery, you will fall down. So without friction, you can't walk. So while walking, there is friction. It's wrong to say there is no friction. Without friction, you can't walk. So basically a belt, conveyor belt, pulling a person. So all these are examples of static friction. Is that absolutely clear, everyone? Thank you for all the love from Ethiopia. Means a lot. We have quite a few students from African continent, let me tell you. A lot of African students do watch our videos over here in the JEE English channel. Thank you so much, means a lot. So, my dear warriors, now we understood what is the meaning of static versus kinetic friction. When the surfaces, if you see for one surface, with respect to that, the other surface does not move, it is static, like when you walk. Whereas if the surface moves, slides, it is kinetic in nature. Their behavior, their formulas are also slightly different. That's why we categorize it into two parts. And friction is the component of the contact force. is the component of the contact force. Also keep this in mind. This angle which you see over here, I will call it lambda. This angle which you see over here is called lambda. That lambda is also called as the angle of friction. It is also called as the angle of friction. It is also called as the angle of friction. No doubt, if you just rearrange that triangle a little bit, you will see the hypotenuse will be the contact force. You will see the height and the base. That is the other two sides of the right angle triangle. The height, if I call it normal, this will be basically the friction. So this would be basically lambda. You can use trigonometry in any way that you would like to. Like for example, tan of lambda, which is opposite by adjacent, will be f divided by n, as you can see over here. Okay, so you can use cos, sine, whatever ratio you want. That is the triangle that is formed. Yes, that is the angle of friction. So till now we have seen that friction basically is the component, and yes, it gives us the sense that it always tries to oppose the motion. It always tries to oppose the motion or the direction of that motion. It feels like a bad guy, but sometimes it is also very, very good or helpful in certain processes. We have just discussed the types of friction. This is done. So, okay. Now, let me demonstrate something to all of you using a very, very simple example simulation. Oh my God. Okay. Okay. So let's go to FET. It's got wonderful simulations. So let's go to motion maybe, and let's see where is our friction. Yes, friction is over here. Motion and basics. Yes, so maybe we can use this particular thing. Okay, it's got a wonderful simulation, and through this I will make you explain what friction is going to behave like. Okay, so there we go. We have friction over here, and you can see this wonderful Pandu over here, and he can apply some force on that box, and he can apply the force in the opposite direction and different amounts. You can also change the mass, or you can even change the object, so the surface of contact will be different. You can also probably put these people over here. Ooh, will this push? Oh my God, I don't want this guy to be pushed. It's okay, I'll push this box. It looks very weird. You can also put a dustbin on the top. Very wonderful, amazing. Also, we can see the forces, the values of it. So if he is applying some value, how many newtons is he applying? We can also see the mass. Right now it is 50 kg. Also, we can see the speed and the sum of the force, meaning the resultant force. Right now, as he pushes, there is an equal and opposite force, so the net force is 0, like you can see. Are the simulation details clear? What are the things here? What is the thing here, etc. The speed, etc. Right? Right now, I've chosen normal friction. You can choose lot of friction. You can choose none friction also. Now, when you choose no friction at all, what happens? When you choose no friction at all, happens. Yes, other students from other countries also can join it. Like we have students from Abu Dhabi, Saudi, Middle East, a lot of Middle East countries, even Nepal, Sri Lanka in our courses. Yeah, definitely. Yeah. Yes. Why is it measured from normal? I mean, just a convention, guys. I mean, if it was measured here, then you will say, why is it measured from this? So just happens. Why is sine opposite by hypotenuse? Why is it not adjacent by hypotenuse? Just like that. Okay. No reason for it. Now, or one way to think about it is, if the angle of friction is more, that means friction is also more. You can think why, because if lambda is more, tan will be more, friction will be more. So that way you can think, that's why it is measured like that. Else, if lambda was more, if it was opposite, then friction would be less. It will be counterintuitive. So to make it intuitive, maybe they chose it like that. Now, over here, what I'm going to do, I'm just going to apply some force and see what happens. The applied force is 76 Newton. The net force is also 76 Newton, and I leave it. Do you see Newton's first law? The body will continuously move. Will it ever stop? No. Why? Because there is no body to stop it. There is no force to drag it, to retard it. This is Newton's first law of motion. The Newton's second law comes, if I apply a force in the opposite direction, the momentum changes, and the momentum is decreasing because of the applied force. until it comes to a grinding halt. There you go. There you go. Okay. So you can make it stop by applying the force in the opposite direction. All right. So let's reset this back. Let's get this all again over here. Now what I will do, I will apply some bit of friction over here and see what happens. I'll apply some bit of friction and see what happens. I will apply some force. Do you see 25 Newton force? What is the frictional force? 24 Newton. This is also 24 Newton. This is 30 Newton. This is also 30 Newton. Is the speed 0? Yes. So what kind of friction will this be? What kind of friction will this be? Come on, quickly think and tell me. Will it be static or will it be kinetic, my dear warriors? Will it be static or will it be kinetic, my dear students? Yep. So if I apply the force, the equal amount of force is being applied, opposite direction, the surfaces are resisting the motion. So it is 100% static in nature because it is not yet moving. I apply some large force. Wow. Look at it. Now the friction is resisting it and there is relative motion. 100% this friction is kinetic in nature. Still, now when I leave it also, it is having relative motion between the surfaces. Do you see frictional force is 50? Total force is 50, which is why it is stopping. Newton's second law at play over here. The force will try to change the momentum until it comes to a halt, and once it stops, the friction will also vanish. Now this is kinetic in nature. Gauri, you missed some interesting fun things at the beginning, but it's okay. Join in. You have not missed too much also. All right, join in. You can easily watch the replay at 2x speed. So whenever you apply a force, the frictional force resists it and it is also adjusting. If I reduce my force, friction also reduces. If I increase it, it also increases. If I change the direction, friction also changes the direction. So can I say static friction is an adjusting force and it adjusts as much as you apply and it tries to prevent the sliding motion, but only up till a point. Say for example, if I exceed some force, oh my God, look at it. After a certain value of force, then the friction does not increase further. That's it. It has stopped to increase. So there is a limit till which the friction can adjust itself. After that, the friction enters into the kinetic zone. After that, the friction enters into the kinetic zone. Awesome. Smile. Abdu, you can do one thing. You can leave a comment. I will definitely leave you a link of our course page. Okay. After the session is over, you can leave a comment. Yep. So this is how static friction changes into kinetic friction. And the interesting part about kinetic friction is once it goes into the kinetic zone, once the surfaces start sliding, no matter how much you apply the force or decrease it, the frictional force remains the same. It does not change. Unlike static friction. Let's stop it. Let's stop it and see what happens. Okay, once it is stopped, then you can see the friction adjusts itself because it is static in nature. This is cool. So here the limit of friction was probably around some 60 Newton or something. After 60 Newton or something, you know, it goes into the kinetic zone. What would happen? What would happen if I added more mass? I don't think it will move at 60 Newton or so. It will move at more Newtons, maybe close to 120. See that? So at 120, 130 Newtons, it begins to move. You can see that. Yes, it begins to move. So that means the limit of the friction which is there also depends on the normal force of interaction between the surfaces, which is directly related to the weight. So more the weight you add, more is the normal reaction, more difficult it is to move this into motion. You can see the frictional force has also increased. Why did it increase? Not exactly because of the weight. Yes, weight has indirectly caused it, but it is the normal force which has increased, which has caused an increase in the frictional force. Got it, my dear warriors? Yep. Anjad will be coming to that inclination related problems, tan lambda, etc. in a bit. Hold on. So from this, we get some clear-cut pictures of mathematical expressions and the types of friction, etc. So in most of the problems, you will have maybe the normal, maybe mg, maybe you will have some external force, and maybe you will have this internal force, which is your friction, and this friction could be either static or kinetic. So, you know, maybe as a result of all of this, this body might be accelerating as such, or maybe not accelerating. So if static in nature, if it is static, then acceleration will be 0. Then maybe your frictional force will be balanced by the external force. But if it is kinetic in nature, acceleration exists, and then your external force minus the kinetic friction will be mass into acceleration. That's how you will solve the problem. This force minus this force is the resultant force. That resultant force is mass into acceleration of the body. That's how it would be done for kinetic. For static, you will just be balancing all the forces anyways. Now, talking more about the values and the formulas for, one second. First, for static friction, then for kinetic friction, I've already given you some examples and what it is, but some more pointers over here. It is self-adjusting. It is self-adjusting force. It is self-adjusting, we saw that. Kinetic friction, you saw, it did not change. It is not self-adjusting, rather it is constant. It is constant once in motion. It is constant once in motion. Next thing is the direction part. Kinetic friction always opposes the relative motion, meaning if one surface moves like this relative to the other surface, it is moving relatively right side, kinetic friction will act left side. So it always opposes relative motion. That's the direction part. It always opposes a relative motion. But in static, there is no relative motion. There is always tendency to move. So it opposes the tendency to move because there is no actual motion. So it opposes the tendency of motion. Tendency of motion. It opposes the tendency of motion. Next important thing, there is a limit of the static friction. Limit of the static friction, which is basically called Fs max. In this case, like I said, kinetic friction is constant for all velocities. For all velocities which are not equal to 0. It does not change. So what is this limit of the static friction? That limit of the static friction, Fs max, is proportional to the normal. So replace that proportionality with a constant, which is mu s. This mu s is basically called as the coefficient of static friction. Coefficient of static friction. It will be given to you, or it will be given as a table or something like that. It has to be calculated experimentally. You do not have theoretical values for it. Same way over here, kinetic friction, like I said, is constant. It is also proportional to the normal interaction between the surfaces. It is actually mu k into n. This mu k, just like coefficient of static friction, this is coefficient of kinetic friction. This is coefficient of kinetic friction. Very, very important. This is coefficient of kinetic friction. Like I said over here, static friction is self-adjusting and there is a limit to it. That means usually your friction which you experience is more than or worst case equal to 0, but it is always less than or equal to mu s into n. So there is a range of values. You can see there is a limit. This is the limit of the friction. Here then there is no friction. There is no friction when there is no tendency to move at all. But it can have a range of values between these two. But kinetic friction is always going to be a constant, which is mu k into the normal force. I hope this is clear. Mu s and mu k values are usually given to all of you. Now, What is the difference between limiting friction and static friction also? I'll just show it to you right over here. Just take this example only. Just take this example only. I am pushing it. Do you see I'm applying? Okay, let's do one thing. I'm applying 50 Newton force. How much force is there? 50 Newton. Which friction will this be? Static. I reduce it. 44. This also became 44. What friction is it? Static. Why? Because it is not moving. This is static friction. Not yet reached the limit. Why? Because it has not yet started moving. If it starts moving, this speedometer will change. 51, not yet moving, it is static friction, static friction, static friction, static friction, static friction. Keep an eye over there. Okay, 56, not yet moving, 57, not yet moving, 58, not yet moving, 59, not yet moving. Okay, 60, not yet moving, 61, not yet moving, 62, not yet moving, 63, wow, not yet moving. Okay, lot of force is needed, looks like it. 66, not yet moving, 67, oh, started moving. Did you see? 66 onwards, it started moving. So 66 was the limit of the friction. That's it. So 66 is limiting friction. Before that, whatever you got was in general all the ranges which the static friction can occupy. Got it? Now the friction which has come, what is this? Kinetic friction. Did you see the limiting friction was 66, but kinetic friction is 50? Why is that so? Why is it that Fs max is, why is it that Fs max more than, why is it that Fs max generally more than your Fk? It's because it's always harder to start or initiate motion against friction against a rough surface as compared to sustain or maintain the motion between surfaces. You would have experienced this in real life also. To start something is difficult, but once you start it, to maintain it is always easy. That's because whenever two surfaces are in contact, there are a lot of cracks, peaks, valleys, uneven surfaces. These uneven surfaces interlock with each other. So when you try to push, this interlocking is hard to break. But once the interlocking goes, then the interlocking does not happen once there is relative motion, because there is hardly any time for the peaks and valleys to, interlock among themselves. They will just go from the top. They'll just go from the tops. They'll just slide from the top. So that is why kinetic friction is less and static friction's limiting value is more. I am not saying static friction is more. I am saying limiting static friction is more. Get the difference, because static friction can take many values. This value I am talking, Fs max, is always more than Fk. So which means what? Which means also what? Mu k will also be less than mu s. Mu k will also be less than mu s. But usually what happens? Usually, for example, say mu s is equal to 0.723, okay, and mu k is basically 0.721. You can say almost they are the same. So what we say, mu is approximately 0.72. So mu is 0.72. So when I do not put any subscript, it is understood that the values are very close by, okay, so which we can completely ignore the difference. Can we say it is because of inertia? Yes, inertia also plays a role. Plus, it is also the interlocking time which does not allow, the friction to exceed a certain value. The interlocking time. So once they begin to move, there is not enough time for that body to again get interlocked. It will just, before it goes inside, it goes to the next part. So there is relatively less friction. Is that okay, Nikhil? Yep, everyone? Everybody understanding this point? Now, tell me one thing. If we plot a graph, oops, this guy is still moving, huh? If we plot a graph of the static friction versus, or sorry, in general friction versus the force which you apply, you will notice that the static friction self adjusts itself till the limit, but once the limit is breached, it goes into the kinetic zone, and no matter what you do, no matter how much force you apply, the kinetic friction remains the same. You can see that additional force will cause the acceleration, but it will basically not change the value of the kinetic friction, which means if you draw that graph, it will look somewhat like this. The applied force versus the friction, it self adjusts till the limiting friction is reached. After that, it reaches the kinetic zone. So this value over here was your Fs max, and this range over here is the range of Fs, static friction, and this value over here that you see, this one is basically Fk. That's why I said Fs max is always more than Fk. Everybody clear to this point? Understood? Shall we go ahead? Yep, understood this particular graph. How this goes? You apply more force, static friction will increase. You remove the force, friction will reduce, self-adjusting till a limit. Beyond that limit, it will suddenly drop and enter into the kinetic zone. That's what happens. So these are the basic formulas, guys, for solving the questions. So I think let's probably look at some questions and see what exactly happens in all of them. Okay. Madharaj, depends on which book you are following. Roughly, give or take, there are around 30 chapters. So totally 80 to 90 chapters overall. Depends on, some books might have more chapters because they classify or label the chapters differently. Okay, so it depends, but roughly give or take 80 to 90 chapters overall for all the three subjects together. Suppose a block of mass 1 kg is placed on a rough surface and a horizontal force is applied. Now let's see what are the values of the force for friction and acceleration if the force is gradually increased. Mu s, mu k and g, everything is given. So let's create duplicate and see what is the thing over here. Mu s is given, mu k is given. Let's do one thing. Let's first find Fs max. What is Fs max going to be? If you draw the free body diagram, things will be very obvious. Our force is here. There will be a normal force like this. There will be obviously mg which is acting downwards, and friction will try to oppose it, and acceleration, if any, will be present here if it is in motion. Other than that, acceleration won't exist. Okay, so now let's do it separately for both the times when first acceleration is not there versus acceleration is there. So first time acceleration is not there, that means it is at rest. For example, it is at rest. Second time, what will happen? Acceleration is there, that means it is in motion. So this friction which you show over here should be probably kinetic in nature. In this case, it is probably static in nature. Okay, so what is the value of Fs max? Fs max is mu into n. What is mu? Mu is 0.5. So let's put 0.5. What is the value of normal in this case? I think it is mg. But is the value of mass and g given? I think so. Mass is 1 kg and g is basically 10. So I think it should be 5 Newton. So the maximum limiting force is 5 Newton. Maximum limiting force is 5 Newton. So if I show a small table, here is our external force, here is our friction. And if I put different values of the external force, I don't apply any force, friction will also be 0. I apply 1.5 Newton, this will be also 1.5. I apply 2.3, this will be also 2.3. I apply 4, this will be 4. I apply 5, this will be also 5. So this is the limit till which you can increase it. Beyond this, it will go into the kinetic zone. Beyond this, it will go into the kinetic zone. As you slowly, gradually increase the force, friction will also adjust till 5 Newton. Everybody fine till this point? Now, let's go to the next part where it goes into the kinetic zone. So, once you go into the kinetic zone, what is Fk? Let's find it out. Fk. Fk is nothing but mu k into n. What is mu k? It is 0.4. N is m into g. G is 10. So it is basically 4 Newton. Kinetic friction is 4 Newton. So once it is in motion, the frictional force which will act will be 4 Newton, constant, which is kinetic in nature. So say for example, let's take a small table over here. Let's take a small table over here. Here is the external force, here is the kinetic friction, here is the acceleration. We all can see in this diagram, this external force minus kinetic friction is mass into acceleration. Therefore, F minus kinetic friction was always 4 Newton is equal to mass, which is 1 multiplied by A. So say for example, I applied a force of 5 Newton and the kinetic friction is 4 Newton. 5 minus 4 is 1. So acceleration will be 1 meter per second square. If I apply 6 Newton force, 6 minus 4 is 2. 6 minus 4 is 2. The acceleration will become 2 meters per second square. If I apply 10 Newton force, 10 minus 4 is 6. 6 will be the acceleration. 6 will be the acceleration. Is that clear, my dear warriors? Everybody with me? Understanding how things work? So as you increase the force, the acceleration will keep on changing depending on the difference of it. Have you now got the idea of how static versus the kinetic frictions work? Everybody, let me know. Okay, so I explained you in detail what is the calculation for Fs max given mu s values and also Fk given the mu k values, and how Fk is also less than Fs max, and how the static friction is self-adjusting whereas kinetic friction is not. All these things are absolutely very clear. Always start off with such questions to gain the concept. Whenever you ask me, sir, how do I gain the concept? How I'm not able to solve difficult questions. Always solve these questions first to gain the understanding of the topic at hand. Let's move now to the next one. There is a body of mass 10 kg moving with the initial speed of 20. The body stops after 5 seconds due to friction. The value of the coefficient. Coefficient is not given. They have asked what is the coefficient. So this was asked in JEE 2023. If there is velocity like this, that surface which is there, it will obviously offer kinetic friction like this. The normal force will be here. Mg will be like this. Mg is basically 10g. Nothing else is there, so there will be 100% retardation opposite to the velocity. If you ask me how much is the retardation, I can easily write it as Fk is equal to mass into acceleration, but Fk is mu k into normal, mu k into normal. So mu k into normal is basically mg is equal to ma, gets cancelled. So basically mu k is nothing but a divided by g, but I don't know a, I know the value of g for sure. Can I find out the acceleration? Why not? Initial velocity is given, time is given, and it stops. So using v is equal to u plus at, final speed 0, initial speed 20, acceleration unknown, in fact it will be negative, so minus a into time 5. So therefore what do I get is 5a is 20, or acceleration, which is retardation, is 4 meters per second square. Substitute this 4 over here, that means the value of mu k will be 0.4. So 0.4 means C option is the right answer. C option is the right answer. Everybody with me? Understood this point? Clear? Very good, very good, awesome. So this is how you solve these questions. 1 second. Great, perfectly understood, awesome. Let's move on to the next question over here. Find the minimum force required to keep the block at rest. Coefficient of friction is given, mass is given, some force has to be applied so that that block remains at rest. See, you might have always tried this. You hold something against the wall and it stays there. Why does it stay there? Let's understand by drawing the free body diagram, of course. So starting off by drawing the free body diagram. If you push it like this, with this external force, 100% there will be a normal force right over here. Apart from that, the weight of the 3 kg block will be downwards. mg, m is 3, so 3g down. Because it wants to slide down, the friction will oppose the tendency and hence the static friction will act like this. Now the question is minimum force required to keep it. See, think like this. Think like this. If F balances normal, because in the horizontal direction, in x-axis, you can see that. If somebody increases the force, the normal will also increase. Normal will also increase. Once the normal increases, what happens? Fs max will also basically, which is mu s into n, that will also increase. That means the limit till which it can hold the friction will increase. You want to find the bare minimum force to hold it. That means you will try to keep as less force as possible to just hold it. So the normal is not too much. The static friction is not too much. It is just barely enough to sustain the weight. Which means, think of it like this, as if the friction has now turned into just Fs max. It is just barely holding it. It is on the verge of sliding down. And Fs max is holding the weight down, which is mg. Which is holding the weight down, which is mg. And Fs max is nothing but mu s into n. So that is equal to mg. But the normal force, like you can see over here, is F over here, which is equal to mg. So our F will be, this will be the bare minimum force. This will be the bare minimum force. This will be mg divided by mu s. What is m? 3. What is g? 10. What is mu s? It is basically 0.6. So what will happen? 3 goes with 6 2 times. So this will be 0.2 times. So guys, this will be 100 by 2, which is nothing but 15 Newton. So that should be the answer. Okay, 50 Newton should be the answer. Is that clear? Everyone? Understood how to solve this question? Pakka? I'm not sure why you said 18. No, it's not 18, guys. Yeah. A lot of times people write normal is equal to mg. See guys, normal is not always mg. Here normal was equal to F. So be careful about it. Don't think always normal is equal to mg. That is wrong. Okay, it can be something else also. So go from problem to problem. Great. Let's move to the next kind of question, which is also very, very interesting. Let's have a look at it. In this particular figure, coefficient of friction is given between the mass m and m. So you are pushing both the blocks by applying a force, but this block is not falling down. Why is it not falling down? Because you applied enough force, so that mass has enough friction to hold it against that vertical surface. Just try to visualize it for a moment. Imagine both the blocks moving simultaneously together and they are not able to slide with respect to each other because the friction is able to hold them. I think you will be able to recognize it only when you look at the free body diagram. Let's draw the free body diagram, of course. Starting off with taking the whole system together. Let's take the whole system together. Why? Because the whole system will accelerate. Do you guys agree with it? The whole system, m plus small m, will definitely have some kind of acceleration together. Can we find that acceleration? I think so. There is only couple of forces acting on the system as a whole. There is one force F over here. There is this combined normal and there is this combined weight over here. In the horizontal direction, only this force is there. In the adjoining figure, the friction is only between these two things. Bottom surface is, remember, smooth. This surface is basically smooth, so no friction over here. So I can then say that this capital F is equal to m plus small m into a, that is the acceleration. Therefore, I get this acceleration as F divided by m plus m. I'm getting the combined system's acceleration. The whole system is accelerating together. The whole system is accelerating together. All right. Ashwin, you're new to the channel. How to take a test? I'll just show it to you in a bit. Just remind me after this problem. Let me just go with the flow of the problem for now. Okay. Or else I will lose my thought process. All right. Till now, I hope this is clear. Okay. How we have drawn the free body diagram, etc. Great. Now, tell me one thing. If the force has to be such that I'm able to hold this mass without sliding down, I need to obviously look at the smaller mass. Why the hell is it not going down? So I will just consider the small m mass. I will just consider the small m mass and just look at it. What is happening so special to that small m mass? Why is it not falling down? I will ask the mass m, what are the forces acting on you? Mass m will say, listen, I have my own weight mg. Also, the capital M mass is applying some normal force on me. And because I have a tendency to fall down, that's why friction will act upward and the friction is preventing my motion from falling down. But then comes another thought. How the hell is the friction acting when normal has nothing to balance over there? How the hell is friction there when normal is the only force in the right direction? So who is balancing normal? That thought comes in your mind, isn't it? So now think, why is there normal at all? I know, yes, you are pushing the system together, so the normal will be there between these two masses. But why is the normal coming in the free body diagram? Who is there to counter it, or what is this normal doing? There are two ways to look at it. If you are a ground observer, standing on the ground surface, you will see the entire system moving. You will see this mass accelerate. So you will say the normal is causing the acceleration. But if you choose the frame of reference, of m plus m, this becomes a non-inertial frame. So this non-inertial frame is accelerating like that towards your right hand side. So there will be a pseudo force like this given by the mass of this body into acceleration of the frame. So this pseudo force is balancing the normal, and this object will appear to be at rest. This mass will appear to be at rest in that frame because this whole thing is moving together. Just imagine both of these are moving together. So if I'm sitting on the big guy, the small guy appears to be at rest for me, not for the outsiders. Make sense? Yes. So it's the pseudo force. So I can just simply say now that listen, the normal force is balanced by the pseudo force. The pseudo force is mass into acceleration. The acceleration from here is F divided by capital M plus M. Fair enough, that's the normal force. But going forward, I will say, wait a minute, this friction should balance mg in the limiting case. So when it reaches the maximum limiting value, when it is on the verge of sliding, it will reach limiting value. It is just being prevented from sliding down. It is the limiting value of the friction. That would be equal to mg. Fs max is mu s into n. This is equal to mg. So going forward, oops, I don't have much space. I don't know where should I write. Maybe I'll write it over here. Yeah. So, oops. So mu s into normal. Normal is this whole thing. M into F divided by capital M plus small m is equal to small mg. M cancels. Whatever we asked. And the coefficient of friction between the wedge and this thing is mu. Question is find the minimum force required to keep the blocks moving. Okay, so we have to find capital F. So therefore, capital F is equal to M plus small m goes up, multiplies with G, the whole thing divides by mu s. So this is the answer. So this is the answer, guys. Okay, M plus M into G divided by mu. M plus M into G divided by mu. Is that now understood how we solve this question? Yeah, we'll be doing it later on. I'm so glad, Nikhil, you understood it now. Yeah, and especially how we look at small m, it's up to us. Remember, frame of reference is always your choice. Never will we go wrong, no matter what we choose, but it's a matter of convenience. Even if I was an outside ground observer, still I would write this same equation. Just think about it. A ground observer will say normal force is causing the acceleration. He will also write the same equation. A non-inertial observer will also write the same equation thanks to pseudo force. So pseudo force helps a non-inertial observer frame the Newton's laws of equation without any miscalculations. Great. So it's a beautiful question altogether. And let's move to the next question. But before that, I think somebody had asked a doubt. Where do we, oh my God, this guy, oh, why is it even not stopping? Oh, it stopped now because I think the animation. Please stop, man. How much will you move? Stop. Okay. Finally. All right. So as you're watching this video, guys, let me remind you that in case of any test series, there are multiple options that you have. Oh, first of all, like the video, guys. What are you guys doing? Just watching the video for free. Don't do that. So you can see the Tatva books are over here. This is for your regular practice. Level 1, level 2, level 3, level 4 with the theory, with solutions, with PYQs inside this book. Okay. You have the jungle book over here where we put up all the lecture PDFs, notes, videos, everything. Okay. So this is like one single collection. You need to log in, create your free account. You want the test series link is over here. The best test series for mains and advanced, it's the Ekalavya test series. And this test series has mains plus advanced, it is for 1350. The link is over here. Is that understood? So this is the test series link. Yep. It is a year-long test series with topic-wise part tests, half tests, full syllabus tests, and all India level ranking tests, both for mains and advanced. That is the test series. And some of you are asking, sir, where can I join any batch? This is the batch which you can join, Ekalavya batch. Click on this particular link. There you get Ekalavya batch, which is right now the best batch for mains plus advanced. In this batch, we are targeting, you will be writing mains only once, that is in January. You will not be writing mains in April. You will be writing it only once. Why? Because we want you to prepare for 5 months for advance. That is the level of confidence we are going to put up in this particular batch so that you clear off mains in the first go so that you are tension free. April attempt, chumma you might give it for the sake of giving. That is the true sigma. That would be the true sigma. Yep. Deepak will be doing it later on, my dear bacha. Okay, let's do this question which was asked in 2021. A block of mass m slides on a floor. Net force is applied at an angle as shown. The coefficient of kinetic friction is mu k. The block's acceleration is given by. Wow, what a beautiful question, guys. Look at the options. The options only look so scary, right? The options only look so scary. But let me tell you, it is not so difficult once you start solving it. Hello, Usha Kanan. Good evening. Good evening. Sir, in that test, all our 12 chapters need to come. No. It is not 12th. It is 11th and 12th both. None of our programs which are for JEE 2025, they are not for 12th. They are for 11th and 12th together. How can we only do 12th? Because you have 11th portions also, no? So it has 11th portions, separate tests, 12th portions, separate tests, then combined tests, full syllabus tests, all India level tests, both for mains also and advanced also. Okay? So they are topic wise. All right. Great. How do we do this question? Let me start by creating duplicates. I love duplicates. So let's get rid of all the unwanted stuff. Like this one, I don't need this. Oops. What should we do? We have been asked, what is the acceleration of the block? And the force is at an angle. And I also know that there is friction acting in this scenario. No issues. Let's start by drawing the free body diagram. One will be mg, which is acting down. Next, the normal from the bottom surface, right? The normal from the bottom surface, it will be like this. This force which is there, I can split it up into two components. One component here and the other component here. This component closer is cos, C for cos, C for close. So F cos theta, the one which is far, you committed a sin. So F sin theta. And as a whole result, you are accelerating in this particular direction. And obviously the friction will resist your motion. Because your accelerated motion, it is kinetic in nature. So this friction should be kinetic. These are all the forces with the effects, with the resolved components of this diagram. Just check. Have you missed anything or what? Soumya, if you have joined the Ekalavya batch, no need to buy the test series separately. It will be a part of it. It will be a part of it. For those students who feel that, no, I already have very good coaching, everything is at par, I will get very good rank with this coaching, then you don't join Ekalavya batch, no issues. You just join the test series because you will always have a second opinion of the kind of questions which are asked. Usually, most of the good students, anybody who is seriously aspiring, the top, 30, 50,000 students usually join, one additional test series apart from their main coaching, just to get a hang of different things. Even I had done that when I was writing my JEE. So, because we'll get a feel of how the tests are. All right. Now, how to do this particular question after this? You can see this and this together give this acceleration, but this friction is mu into n, but normal is not mg. The catch is normal will not be mg because of this F sin theta component. So actually speaking, in the y direction, the normal force plus the F sin theta, which is vertically up, is being balanced by mg. So technically, normal is mg minus F sin theta. Crazy, isn't it? Normal is not mg, it is mg minus F sin theta. Okay, I hope this is absolutely clear. Next, in the x direction, you can see this force minus this force is mass into acceleration. So I can say F cos theta minus Fk will be mass into acceleration. What is Fk? Fk is mu into normal. So that is mass into acceleration. But wait a minute, what is normal? What is the normal force? Get it from here. So it is mg minus F sin theta. This is equal to m into a. Perfect. I think I can bring all the f's together. So what I can do is f and into cos theta minus becomes plus mu times sin theta. Okay, mu times sin theta minus mu mg is equal to m times a. Divide the entire equation with m and write acceleration on the left hand side. So we'll get f divided by m cos theta plus mu sin theta minus mu g. That is the acceleration, guys. That is the acceleration, my dear warriors, which is exactly the same equation. They have written f separately over here, but you can combine them together, you will get the same thing. F by m cos theta minus mu k g minus f by m sin theta. One and the same thing. Got it? Understood? Oh, clear? Herborine, very good. Proud of all of you if you got the answer correctly. Very nice. Excellent. There is this one interesting question which I have seen, which comes in many books also. And you would see that there is a box which would be given to you. There would be a box which will be given to you, maybe of, excuse me, maybe of 2 kg, and it is dropped, and it is said that it is dropped on a conveyor belt, which is probably moving at some speed, maybe 20 meters per second. Okay, 20 meters per second. Question is, how much time will the box slide? How much time will the box slide on that conveyor belt? This kind of question is also very, very common. Let's understand what is exactly happening over here. See, you drop the box, that means the box had 0 velocity, but the belt below has some velocity which is 20 meters per second. Once you See, the box is in contact with the conveyor belt. Don't you see there will be relative motion? Because there is relative motion, there will be friction. Which direction will the friction act? 100% towards the front, because the friction will pull it. The friction will pull it and it will be kinetic in nature. The friction will drag that box in the front. So 100% there will be some acceleration of that box, because of which the box will get some velocity. Maybe after some time it gets a speed of 4 meters per second. Just chumma taking some random value. The belt meanwhile is still moving at 20 meters per second. The belt is moving faster than the box. So there will be relative motion, hence the friction will continue to act, because of which the friction will cause certain acceleration. So that acceleration will still be there. This will continue as long as there is relative motion, as long as there is some kind of relative motion. Even when it is 19 meters per second, the belt will still be moving little bit faster. So there is relative motion. So the box is moving slower, so the friction will pull it. And because of that, there will be some acceleration. And all of this will come to a halt. I mean, the friction will stop acting once the box reaches a speed of 20 meters per second, the same as the speed of the conveyor belt. That's the moment when there will be no friction, because there is no slipping, and hence the acceleration will be zero. And that's why this velocity of 20 meters per second would be a constant velocity. So you drop something, it slides and then it is dragged and it is going to achieve the same speed as the conveyor belt after some time. Are you able to visualize this step-by-step process? Okay, couldn't get the direction of friction. I'll give you one more example. Imagine there are two surfaces. This is one surface and this is another surface. Okay, let's take many examples like this so that every one of us is absolutely clear about the direction of the friction. In this case, the speed is 5 meters per second. Here it is 15 meters per second. Here it is 20 meters per second, like this. Here it is 8 meters per second. Example. Here I tell you, listen, it is 7 meters per second. Here I tell you, listen, it is 8 meters per second. Here I tell you, listen, it is 6 meters per second, like this. Here I tell you, listen, it is 17 meters per second, like this. Okay. I've taken some random examples. Orange one is on the top, yellow one is the bottom ground surface. In each case, do you agree there is a relative motion? In each case, do you agree there is a relative motion? Yes? Okay. If there is relative motion, do you agree? Why relative motion is there? Because they are moving relative to each other. Their speeds and directions are not same. Number one. So there is 100% kinetic friction. Now, if there is kinetic friction, what direction will it act? It always opposes the relative motion. So if you think about it, the orange one is moving slower relative to the yellow one, which means relative to the yellow, the orange is moving back. This is the relative motion direction. This is the relative motion direction of the orange surface. Do you guys agree? Because yellow is moving fast as compared to the orange. So the orange is moving behind relative to the yellow one, which means the friction on the orange, the one on the top, should act in this direction. Does that make sense? Apply the same logic over here, you will get the answer. Yellow is moving slow, orange is moving fast in the same direction. So yellow is moving slow, orange is moving fast. So with respect to the yellow, orange is moving in the front. So the relative motion is in the front. Relative motion is in the front, the orange ones. So on the orange, the friction should act backwards. The kinetic friction should act backwards. Is that absolutely clear now? Can you now do for this problem now? Can you now do it for this problem? 20 here, 6 here. What will you do? So think like this. With respect to the yellow, the orange, because they are moving in opposite, so for the yellow, anyways, the orange will move in this direction. So this is the direction of the relative motion. Hence, the friction on it should be in this direction. Take this example. With respect to the yellow, the orange is moving slower. So yellow is moving faster, orange is moving slower. So the orange is actually moving back. The orange is actually moving backwards. This is the direction of the relative motion of the top surface with respect to the bottom. Hence, the friction on that orange will act in the front direction. Clear? Will the reaction forces be there? Yes, Nikhil, obviously the normal forces will be there. Normal forces will be there everywhere. I'm just not showing it because it is obvious. Weight will be there, external forces might be there, tension, normal, all those things will be there, no doubt. So now I hope you understood why this moving slower relative to this, the belt moving faster, the box moving slower, caused the box to appear to move backwards. That's why the friction was in the front. That's why the friction was in the front. Hence, for this entire problem, think of it like this. From the frame of reference of the conveyor belt, actually speaking, our box which was there, was actually moving behind with a speed of 20 meters per second initially, and slowly it comes to a halt. It stops. See if this makes sense. It was actually going behind. The conveyor belt is moving front, the block is moving behind, and finally it stops and they both move together. Both of them moving together, that means they stop with respect to each other. Is that clear, everyone? Understood? Okay, even a simple problem like this has so many concepts which no, or rather few teachers discuss. The forces acting on this, mg, normal, of course. This conveyor belt is not a non-inertial frame, so please do not apply pseudo force. This is highly inertial, guys. If you are asking me why is it not non-inertial, think about it. It is moving at constant speed, zero acceleration, no pseudo force. Be careful. So please don't apply any kind of pseudo forces here. The only friction force which will act in the horizontal will be friction, which will cause that retardation. So just applying Fk is equal to mass into acceleration, Newton's second law, Newton's laws of motion. Friction is mu into n. N is nothing but m into g, because n is mg, balancing each other, is equal to ma. Therefore, acceleration is nothing but mu g. Acceleration is nothing but mu times of g. Right. So mu needs to be given, of course. I don't think I gave the value of mu in the question. So let's say the mu value happens to be 0.5, just chumma giving some value. So therefore the acceleration will be 0.5 into 10. Therefore the retardation will be 5 meters per second square. Now you use kinematic equation. Final, initial and time. So use V is equal to U plus A into T. Final velocity 0, initial velocity 20, acceleration negative because it is retarding, into time. Therefore 5t will be 20, therefore time will be 4 seconds. That's how you find the time taken to stop. Is this question now clearly understood in everybody's head? Shall we go ahead? Okay, all these situations give you an idea of what was happening from the ground frame, but this situation tells you from the conveyor belt frame what was happening and why the friction was here. It's a beautiful, beautiful question. Great. Then we have this another amazing question which is there in level 2 Tatva, probably also asked in one of the previous years. Body of certain mass is kept on a rough surface. Tatva is our JEE coaching book. If you want, you can open up that book or buy that book also with the link in the description. A body of certain mass is kept on a rough surface. Coefficient of friction, I think this should be mu. A person is trying to pull the body by applying some force, okay, and everything else is mentioned over here. So this is supposed to be mu, I believe. Okay. The body is not moving. The force on the surface on A is F. The force by the surface on A is F. Now, when I say the force by the surface on that object is F, what tells you or what does it tell you about F? What kind of force is F? The force exerted by the surface on the object. Is it normal? Is it friction? Or is it contact? What do you think it is? Is it normal? Is it friction? Or is it contact? Quickly think and tell me. Because it is the force by a surface on the other surface, it is nothing but the contact force. 100%. It is nothing but the contact force. The question is about the contact force. What is the range of the values, or what is the value of the contact force? Now I can imagine multiple different scenarios over here. Like this box is right over here. Imagine our external force, horizontal force, which is there is no pull at all. There is no pull at all. If there is no pull, friction will be zero, right? So friction will be zero. So that means there will be only normal, which will be balanced by mg. So in this scenario, when there is no friction but only normal because there is no pull, can you tell me what will be the contact force in such a scenario? Can you tell me what will be the contact force? The contact force will be the normal. Therefore, I can say the contact force is also equal to mg. The contact force is also equal to mg in such a scenario when there is no pull at all. 100%. Imagine you are applying enough pull. This is like the maximum pull which you are applying, and the friction has reached the limiting value. Friction has reached the limiting value. This is normal. This is your mg. This is a pull which is high amount of pull. To just bring it into motion, Fs max has been reached. In such a scenario, your contact force would be like this. Contact force will be like this, and how much will it be? It will be root of n square plus Fs max square. It's the resultant of both of them. But wait a minute. I know what is Fs max. I know what is Fs max, and I also know what is normal. Normal is mg. So it will be basically mg or m square g square plus mu square n square. Mu square n square. But I already know n. But I already know the value of n. Normal is mg. So it will be m square g square again here. Take it outside. It will become mg root 1 plus mu square. Mg root 1 plus mu square. So this contact force, I feel, is the maximum value of the contact force, because when it is not limiting in nature, it is just Fs. This normal is there, this mg is there, your pull is existing. This contact force will not be so much. This contact force will not be so much. This contact force, I think, is the maximum value of the contact force. This contact force, I think, is the minimum value of the contact force when there is no friction. Slowly the contact force increases and becomes maximum. So I think this is the maximum, this is the minimum. So it lies between these two values, which means it should be option number C. Which means it should be option number C. Do you guys get it now? Why option C? Very, very amazing question, guys. Great. Perfect. Let's come to angle of repose concept. So before that, just imagine there is an inclined surface. There is a block over here of certain mass and it is sliding down. So there is some kind of acceleration, and this is theta angle, and the coefficient of friction is basically mu. I want to find out how much is this acceleration. Yeah. Yes, Samita, that would be C max. How, sir, normal will be? Sir, how normal will be the resultant? No, normal is not the resultant. Normal and Fs max's resultant is contact. Normal is not the resultant. Normal will be just balancing mg. This and this combined together is contact force. Contact force is not normal. Normal is just a component of the contact force. And Fs max is mu n, n is mg. N was always mg. So take mg outside the square root. So you will get this. Is that okay? Samita? Harborine, understood. Great. Nikhil got it. Perfect. Yep. Now, in this scenario, when you want to find the acceleration, start off with the free body diagram. Standard forces, guys. Normal will be there. Mg will have two components, of course. One will be mg sine theta. The other will be like this, which will be mg cos theta. Friction will oppose the relative motion, so friction will be like this. So that would be Fk. That's it. Those are the only forces. So if you take perpendicular to the inclined plane, the normal force is being balanced by mg cos theta, which gives you no resultant. So normal is equal to mg cos theta. Along the direction parallel to the inclined plane, this force minus this force is mass into acceleration. The downward force is mg sine theta, opposing force is friction, is mass into acceleration. So mg sine theta minus friction is mu into n is equal to mass into acceleration. So therefore mg sine theta minus, what is the normal force? It is mg cos theta. Mg cos theta is equal to ma. So you can see mm gets cancelled. So I will be left with g sine theta minus mu k g cos theta is equal to a. Therefore the acceleration would be g common sine theta minus mu k cos theta. That's the acceleration of the block sliding down. It depends on the friction, but it is independent of the mass. If it was a smooth surface, mu would be 0, this will vanish. Acceleration would be g sine theta, which is something which we have seen before. Yeah, acceleration will be simply g sine theta, nothing else. So if friction was absent, but with friction, it reduces the acceleration. Straightforward, everyone. Now, maybe it might not accelerate at all if this inclination is not good. Because think about it, if this theta increases, probably there is a good chance there might be no acceleration at all. Oh, sorry, if this theta reduces, my bad, if theta reduces, gravity will not be sufficient enough to balance out the friction, and maybe it is not going to slide down at all. So if you slowly increase the inclination, the block which was at rest suddenly begins to slide. So there is a range of theta for which it doesn't slide, and it plays a crucial role in many applications. Example, you are a city engineer, you are planning the development of a city. There are some hills, you are making a road. You will make sure that the road is not too steep, so that if somebody has parked the car, imagine within 5 minutes the car is sliding down that road. Why? Because you did not think about the friction. Right? So many different applications you can think of. Any slope that you build, any ramp that you build should be such that if by chance a vehicle breaks down or something is kept on that ramp, it should not slide down, or else everything will start falling down. It will create a complete chaos. So that's why this angle till which you can maintain things at rest is very important, and that angle is called as the angle of repose. That angle is called as the angle of repose. Usually the symbol for that is alpha. So for theta less than or equal to alpha, there is no slipping. For theta more than alpha, there is slip and kinetic friction. And kinetic friction will come into play. Basically the previous slide. Theta was more than alpha in this case. Theta was more than alpha in this case. That's why it was accelerating. Alright. So what is that value of alpha? Very easy, guys. Again, mg cos, mg sin, mg f, everything, all the forces are already shown. So when we have to talk about the condition for no slip, this friction will be Fs max actually. This is Fs max. Acceleration is 0. And I can just say mg sine alpha is being balanced by the friction over on the top. They are all balanced because acceleration is 0. Fs max is mu s into n, but normal force is mg cos alpha Normal is mg cos alpha. So this is mg sine alpha. Mg cancels. Sine alpha is mu s cos alpha. Take cos below. So sine alpha by cos alpha is mu s. Therefore, tan of alpha is nothing but mu s. A very important result which you are seeing over here. This alpha is nothing but tan inverse of the static friction, which means, say for example, mu s was 1.73. Mu s was example 1.73. So in that case, if I use this formula, tan alpha is mu s, which means 1.73. This looks like root 3, almost root 3 value. So tan alpha is root 3. Therefore, whose tan is root 3? Obviously 60 degrees. Which means 60 degrees is the maximum limit till which the box will be at rest. If you put it even less, no issues. Even if you put it less, let's say 40 degrees or something, it will be at rest. Here also it will be at rest. But the moment you put even 61 degrees, that's enough. The box will begin to slide. That is the meaning of it. Yes. You can take anything. Phi, psi, theta, alpha, whatever you want to take. Okay, doesn't matter. There is another interesting application of this angle of repose. I think I should have put it. Yes. In fact, this was also one of the question in JEE last couple of years. If you put sand, have you seen the sand makes a conical shape? If you keep pouring sand, if you have gone to the beach or played with the sand, have you seen the sand makes a conical shape like this? Have you seen that? Yes or no? Do you know there is a particular reason why it makes that conical shape? Because imagine if too much of sand accumulates on the top, then the slope will become too high and the sand particles are free to move. They can slide on each other. So the sand particles will slide if the angle is too steep. But if the angle is lesser than the angle of repose, these sand particles won't be able to slide with respect to each other and they will stay still. So the maximum inclination of the cone is the angle of repose. That's the maximum angle. Isn't it an amazing phenomenon that your sand heap had this concept of friction? So if you know the coefficient of friction between the sand particles, you definitely can find the angle made by that cone at the base. Angle made by the cone of the sand at the base. It's a beautiful application. Great. Cool. Let's move ahead. I think this I have already told what is angle of friction already. So that is done. So let's move to some questions. There is some particle which sits on a rough surface with some 30 degree and is just about to slip. Find the coefficient of friction of the plane and the particle. Since it is mentioned just about to slip, that means this particular angle must be the angle of repose, 100%. Hence, tan of 30 degrees should be mu s. Therefore, mu s will be 1 by root 3. That is the answer. Tan 30 is 1 by root 3. So that should be the answer. Perfect. If it is on the verge of slipping, that means it is just about to slip. Friction is limiting in nature. It will be 1 by root 3. How will it form a cone? I mean, just think about it like this. Imagine there is some sand, you pour it like this. If you see at any given point, if the angle is very steep, what will happen at that point? The sand particles which are there, they will start sliding down. The sand particles will start sliding down and you will see that this top part will vanish. It will go down over here. Right? And this will be true in all the 360 degrees. this side, this side, this side, this side. So that's why it forms a cone. Making sense? Yep, very good. Very straightforward question. Moving on to the next one. What is this? 2019 question. Level 2 question. A block is kept on a rough inclined surface as shown in the figure, remains at rest up to the maximum force 2 Newton down the incline. Maximum external force up the incline so that it doesn't move is 10 Newton. The coefficient of static friction within the block and the plane is. Amazing question, guys. There are two situations. Let me just create duplicates and then start solving it. Okay. First, let's ignore this part. And then let's ignore this part. Because there are two different scenarios. The thing remains at rest for a maximum force of 2 Newton. That means, you know, this block without this force would not slide down. You need to pull it down with an additional force so that it slides. That means 30 degrees is lesser than the angle of repose, or the angle is not sufficiently high, so it is not sliding on its own. You need some additional force. That's one thing. Let's also show the other forces acting on the system in this scenario. Obviously your mg cos is there, mg sin is there, normal is also there. So I'm just showing all those things. Is m given by any chance? Acha, no, it is not given. So mg sin 30, this will be mg cos 30, and the friction will oppose the tendency to move. So this Fs max will be like this. So in this scenario, I'll just say 2 plus weight sin 30, weight sin 30 is equal to Fs max, and Fs max is mu into n, where n is weight cos 30. Substituting the values, so 2 plus sin 30 is 1 by 2 is mu into w into root 3 whole thing divided by 2. That is what I get right from here. This I will just call it as equation number 1. I'll just see what to do with it later on. For now, I'll just keep it like this. Next up, when you try to pull the block up, again, your mg sin and mg cos is still there. Mg, which is the weight, cos 30, and mg sin 30, and of course your normal is still there. But now it wants to slide up. Friction is not up. Friction always opposes the tendency. So that's the reason why the friction acts down. So Fs max is down, and this was the biggest catch in this problem in 2019. Many students wrote the Fs max in the upward direction. They got a wrong answer. Did you understand why Fs max is down? Because it wants to slide, because it wants to slide up. Friction always opposes the relative tendency. So it wants to slide up, so friction will oppose that. So in this scenario, I can say the weights sin 30 component additional to the Fs max is balancing the 10 Newton. Sin 30 is basically half. Fs max is mu into n, n being weight cos 30 is equal to 10. Therefore, w by 2 plus mu into w root 3 divided by 2 is basically 10. This is your equation number 2. This is your equation number 2. So now we have two equations. This one with two unknowns, mu w and also mu w over here. You can just substitute one with each other and you will basically get the answer. Okay. If you want w by 2, you can substitute it. Where did it go? If you want, take this w by 2 and substitute it in this one instead of this. Okay. You will get one equation, or you can get rid of mu w root 3 by 2 first so that you know the value of w, and then you can start solving the problem. So say for example, from this equation, you see mu w root 3 by 2 is 2 plus w by 2. Mu w root 3 by 2 is 2 plus w by 2. This thing is 2 plus W by 2. So I just substituted it over here. Rest of the things as it is. So W by 2 plus this is equal to basically 10. So W by 2 plus W by 2 is W. 10 minus 2 is basically 8. So I get weight as 8 Newton. Now once I get weight as 8 Newton, you can use this or any other equation and you will get the answer. So if you want, you can substitute this back, let's say over here in equation 2. So what do you get? So weight is 8. So 8 by 2 plus mu into 8 root 3 divided by 2 is basically 10. 2 and 8 goes 4. So 2 and 8 goes 4. So 4 root 3 mu is equal to 10 minus 4. That 4 will go on the other side, which is 6, which is 4 root 3 mu divided by 2, 3, divided by 2, 2. So 2 root 3 mu is 3. So basically mu will become 3 by 2 root 3. 3 by 2 root 3. Root 3 cancels. It will become root 3 by 2. That's the value of your mu. Root 3 by 2. That is the answer. That is the answer. Got it? How we solve this? Yes, Harborine? Option A is the correct answer. Perfect. We have got it. So it was just 2 equations, 2 scenarios. You have to draw 2 separate FBDs. Many people didn't even draw separate FBDs. In that only they took everything and they got wrong answers. So always draw clear cut diagrams. Don't make your rough work messy. That's where your silly mistakes happen. Going to the next question on your screen. If the coefficient of friction between an insect and a bowl is given to you, the maximum height to which the insect can crawl inside the bowl is how much? The maximum height to which the insect can crawl inside the bowl is how much? Alright. Why is there a maximum height? Let's think about it. Imagine this is our bowl, which is like a spherical surface. Imagine the insect at different places, here, 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 here. If you draw tangents at all these places, like here, 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 it feels like the insect is on different inclines. So if the insect is here, it is on a steep incline, versus it is here, it is on a very hardly, any incline is there, any inclination is there. So it will be easy for the insect to crawl here. It will be very tough for you to crawl over here because it is very steep. So you might be exceeding the angle of repose. So in these situations over here, I think your angle is less than the angle of repose. Here, maybe it is so steep that your angle is more than the angle of repose. So for the particular insect which is there. So definitely it will slip in this situation. In this situation, there is no slipping. So there comes a scenario where exactly at this particular point, where that angle exactly equals to alpha. So this is the maximum limit till which this is on the verge of slipping. This is on the verge of slipping. No slipping, no slipping, verge of slipping and start slipping. So there is a point till which you can increase the inclination. So there is a height from the ground till which you can go or crawl up. Okay. Till now, everything is clear. So let's draw this particular bowl. I don't need most of it. All right. Let us take this vertical height. Let us also show the point till which it can crawl. Maybe it is here. Maybe there is a tangent which I can show. Maybe there is a tangent which I can show, which will go like this. This is the steepest inclination possible. Let me also show the ground over here like this. Okay, perfect. Let me also draw the horizontal like this. Okay, perfect. So these are all the things that I have shown in this diagram. So obviously this is the radius. Even this whole thing is the radius of the bowl. Okay. This particular angle that you see over here is alpha. If this is alpha, this is also alpha. parallel lines intercept alternate angles. If this is alpha, this is 90 minus alpha, this is 90, hence this is again alpha. Think about it. Here, this is perpendicular. So if this is alpha, this angle will be 90 minus alpha. Do you guys agree with it? This angle will be 90 minus alpha. Since this is 90 again, this will be alpha again. 90 minus alpha, alpha. Complementary of a complementary is that angle back again. So this is how I show it. And also notice one more thing. If this is R, in this small triangle, you will notice one thing. Only this much, if you notice, it is hypotenuse cos alpha. So it is R cos alpha. Only this much is R cos alpha, and the whole thing right from the top till the bottom, that was R. And what we need is only this much, which is the height. So basically, that height which we want is nothing but R minus, what is it? R minus R cos alpha. You might be wondering what the hell is cos alpha. Don't worry about it again. I'll tell you what. Just draw a hypothetical right angle triangle. Where this angle is alpha. We know what is tan alpha. We know what is tan of alpha. Tan alpha is mu. That means opposite side by adjacent side. Opposite side by adjacent side is mu. That means the hypotenuse must be 1 square plus mu square. So from this, we can see what cos alpha will be, 1 by this value. So cos alpha will be 1 divided by root of 1 plus mu square. So hence, I get the value of the height as R common, 1 minus 1 by root of 1 plus mu square. That should be the answer. Yes, that is the answer. Such a nice question which involved trigonometry, concept of angle of repose, a little bit of geometry also. Did you love this question or no? Did you love and enjoy this question? Yes or no, my dear warriors? Clear? And if you love this, make sure you are liking this video. Yes, these kind of questions might be there in HC also. Why is 1 in the base? Because tan alpha, what was tan alpha? It was mu. So I can write mu as mu divided by 1. So you can think of an imaginary hypothetical triangle with opposite side to alpha as mu and adjacent side as 1, so that I find the hypotenuse, because we just need ratio, trigonometric ratios, so that from tan we can find cos. So whenever you have one ratio, you have to find the other ratio. You always construct a hypothetical triangle, and that's how you can do the interconversions using Pythagoras theorem very easily. Okay. So Ashwin, basically what happened is, in this question there was an insect which was crawling up. So when it was crawling, you can think as if it is climbing on an inclined plane which is getting steeper. So initially it is not so steep, so it is not slipping. But when it becomes too much, it begins to slip. So there is a point of inclination when it is on the verge of slipping. So that inclination will be such that if you draw a tangent to that bowl's surface, it will behave like an inclined plane with the angle of repose as the inclination. So I took that special case over here where I have drawn the tangent to the bowl and it is on the verge of slipping, so that inclination is alpha and this is radius, this is radius. I have done some geometrical construction because I want this height. So this height can be found only by taking this minus this. This I know is radius. How much is this? This is r cos alpha, and I got alpha by geometry. How much is cos alpha? Well, I know tan alpha. How do I know tan alpha? Because it is angle of repose. So I constructed an imaginary triangle. From tan, I got cos, substituted to get the height. Is that okay? Absolutely clear, everyone? And I hope you guys are subscribed to the channel. In case you haven't subscribed, just a quick reminder. And not liked, like it. That's your Guru Dakshina. Great. Now let's go to the next set of questions where you have block on block questions. These are the most important kind of questions where in fact I have done some bit of it over here where you probably got some idea. Where did it go? This one. This is a very, very good explanation of block and block questions. In fact, I can put this slide here also, but it's okay. So if you want, I'll just replicate this slide here. Whenever you have blocks on another blocks, remember, always check what is the relative motion, if at all. What is the relative motion, if at all? Accordingly, decide the direction of the friction. If one block is sliding faster than the other, immediately you can figure out the direction of the friction. But at the same time, let me also remind you, in any of these block questions, just say for example, there is one block here and another block over here, okay? And let's say I tell you, listen, this block is moving with a speed of 20 meters per second, and listen, this block at the lower end is moving at 15 meters per second. So if you think about it, relative to the lower block, the upper block is moving faster. So the upper block has a relative motion over here, relative motion like this with respect to the lower block, Hence, to oppose the relative motion, the friction on it will be like this. Do you guys agree with it? The kinetic friction will be like this. Yes, there will be normal, mg, all those things are there. Okay, normal and mg, everything will be there, but friction will be like this. Everybody clear? Now, if you draw the free body diagram of the lower block, what happens is, if you draw the free body diagram of the lower block, be very, very careful now. Because every force is an action reaction. So if friction acts left on this block, because of this block, on this block, the friction will act forward because of the upper one. This is very important. And the normal on the upper one acts up. So on the lower one will act down from the upper block. Apart from this, there will be its own weight and a lower ground reaction, normal from the ground. These are all the forces which will be there on the lower block. See if you understood this. Main thing is over here, if this Fk was called as the action force, this will be the reaction. Same way, if this normal is called as the action, the reaction will be on the lower block. Newton's third law, guys. So be very careful when you draw the free body diagrams of the lower block, if at all, if necessary. If necessary. Absolutely clear, everyone? Understood? So for these block questions, remember one thing. If the upper block versus the lower block, FBDs are being drawn, and you show on the upper block normal is there and maybe friction is over here, then on the lower block normal will be here and the friction will be here. Normal will be here and friction will be here. Always this works. Always. This is a very important key information when you draw the free body diagrams. Always. And if there are more blocks below, the same things will continue, but usually you get two block problems. That is one key aspect. So this would be your action. This would be your reaction. If you talk about the value of the friction, well, the value of the friction which is there will still be mu k into the normal force. Normal force between these two blocks, whatever it is, it will be Fk into mu k standard. The problem happens when there is no relative motion. When there is no relative motion, that is, there is static friction between them. That's when the major problem happens and people get confused. Imagine there is a block and then there is another block over it, okay, and this is the surface. Let me see if you guys can answer this question. In the first scenario, I am pushing the upper block with some force, nothing is moving, everything is at rest. In the second scenario, I am pushing this block, everything is at rest. The whole system is at rest. I want to show the forces, I want to draw the FBD, I want to find out the friction on both the blocks. All the surfaces are rough, everything is at rest. So, if everything is at rest, net force must be 0. Every surface is rough, maybe all surfaces might encounter friction. In this scenario, let's show the upper block here. Let's show the lower block over here. Remember, everything is at rest. All surfaces are rough. All the surfaces are rough. In the second scenario also, I will do the same thing. The free body diagram of the upper block versus the free body diagram of the lower block. Again, everything is at rest. All surfaces are rough. Okay. Let's start with this one. In this scenario, what are the basic forces? See, fundamental forces, so you draw it as it is. I mean, there is no thing about it. mg will be down, right? There will be normal force over here. That same normal will act over here. There will be weight of this block. There will be normal from the ground, N2. These forces are standard. I mean, even without friction, they will still act. mg will be here. Normal from this surface will be here. And on this surface, it will be like this. The weight of this block will be mg, right? And from the ground, there will be N2. These are your basic forces. Apart from that, there is this additional force in this scenario. And in this scenario, the force is acting over here. Okay. Let's start with this now. First, after drawing all the basic forces, we get some clarity. Now, tell me, for the upper block, because it is at rest, in the horizontal direction, there must be something to balance it, no? There must be something to balance it. What will balance it? Think about it. Obviously, friction. So, 100% on this, the friction will act like this on the upper block to balance it. So, this F1 will be equal to F. If this is action, the reaction on that lower block will be over here. The reaction on the lower block will be towards the right side. Understood? Now look at the lower block. Oh my God, this is also at rest. So what is this friction doing? It will accelerate it, but it can't accelerate. So hence the ground will give a frictional force in this direction because they must be equal. So F2 will be F1, but F1 is F. So F2 will also be F. So F2 will also be F. So these are the frictional forces values and their directions at every single surface on all the blocks. Is this clear? Is this FBD clear and how we got it? How we start with basic forces, how we separate out the bodies, how we analyze the information, how we go logically. We don't jump directly. Oh, let me start with this. No, this is given. So let me start from the upper block and go to the lower block. Understood? Shall we go ahead? Great. Let's go to the second scenario. Now, if you think logically, most likely we should start from the lower block only. But there is a problem. I do not know if there will be friction here and here both, or just on the top or just at the bottom. So let's assume, there is no harm in assumption. Let's assume that on the upper block there is some friction, maybe forward. Who will balance this friction? Tell me. Who will balance this friction on the upper block? Remember, the upper block is at rest. Absolutely nothing. There is nobody. You can't beg any force. Hey, please balance me. I am experiencing some unbalance. Balance me. Nothing. Nobody is there. If you show that frictional force here, it should accelerate, but it is at rest. So the friction can't even act here, which means at this point, the friction must be 0 because it is at rest. Because it is at rest. Because if there is friction, there is nobody to balance it. No pseudo force, nothing. So if F1 is 0, that means over here, the reaction of it will also be 0. The reaction on the top surface of the lower block, friction wise, will also be 0. Which means now we got clarity that the upper surface will not encounter friction. It's only the lower surface. And the lower surface has nowhere else to apply but to oppose this force. So the lower surface will oppose it and it will be equal to F. So between the blocks there is no friction, but between the ground and the lower block there is force of friction left side having magnitude F. What an amazing, amazing question. It shows you how to solve the block problems, especially when they are at rest, especially when they are in stationary condition. Akshaya, yes, you can watch it, definitely. Now, there is a special case of this block on block questions where you might have maybe a block like so of certain mass which is kept on another block over here, capital M. Okay, it's kept on a surface like this. Maybe it is smooth, but there is friction here, and then they tell you, listen, what is done is you are pushing this mass using this force, and question will be to find the maximum force such that there is no relative slipping. Find the maximum force such that there is no relative slipping. What is the ground friction is 0 in case number 1? No, in case number 1, ground friction can't be 0 at all in this case, because if F2 is 0, then who is balancing F1? It is at rest, right? So F2 must be there to balance F1, and F1 can't be 0 because F is there. So there is a logical thought process why all of them are non-zeros in the first case, but in the second case, there is a logical thought why F1 is 0 but F2 is not 0. Is that okay, Nikhil? It's an interesting logical process. Now, in such a scenario, when you want both of them to move together, first things first, because there is no relative slipping and this whole system is on a smooth surface, this entire system as such, which is M plus small m, because of this force will end up accelerating. Yes, there is weight, which is M plus m into G. Yes, there is normal reaction from the ground, but this entire thing will end up accelerating, and we can find this out very easily because F will be M plus small m into A, taking the whole thing as a system. Therefore, acceleration will be F divided by M plus m. I know you must be thinking, sir, what happened to the friction between them? Why have you not shown it over here? That's because in this scenario, the friction is an internal force. And internal forces are never ever shown in free body diagrams. So we have completely avoided that. Okay. Sir, but then why did you find the complete acceleration? What was the need of it? You will see why when I show the free body diagram of any of these masses. Let's say the top one, for example, this small m. When I show the free body diagram of the top mass, one will be obviously its weight, second will be obviously the normal which is acting on it. That mass along with the system is obviously accelerating like this. If there is acceleration, there must be force. Where is that force? Only one thing can provide that force, that is the friction. So the friction is providing this acceleration. If I just look at the mass which is on the top, it is accelerating. So that acceleration of the top mass can only come from the friction between these two surfaces, which is dragging it in the front. Is that making sense? Yep. Sir, I took 712 with your help, sir, only because of you. 712, I didn't understand. What do you mean by that? Okay. Now, if I write the equation, F1 is equal to m into A. Do you see now why I need the acceleration, which I found out here? Without this acceleration, I won't be able to solve it for the friction at all. That's why I need it. That's why I needed to take the entire system over here. Now F1, because you are applying maximum force, it is on the verge of slipping. Because it is on the verge of slipping, this will be actually Fs max. It is on the verge of slipping. Why? Because of the maximum force. Because of that maximum force. Hence, this will be mu into n is equal to m into A, but A over there is F divided by capital M plus small m. What is normal? Normal is small mg. So mu into small mg is equal to m into F divided by capital M plus small m. Small m cancels. Therefore, F will be equal to, check this out, mu into m plus small m into g. That's it. We have found the answer. F is equal to mu into m plus mg. Amazing, amazing question, isn't it? Yep. Let me tell you, there is a variation in this problem where instead of the force being applied here, the same force is applied here, and now the same question is asked. Find the, maximum force which can be applied such that there is no relative slipping. Same thing, but the force is applied on the top. Let me give you a hint. Do the same things, repeat it. You take m plus m. Again, you draw the FBD of the top mass, and yes, it will have some acceleration. This will also have some acceleration. Draw the FBD. You can solve the problem, but this time the force will come out to be slightly of a different value. This particular part, I think you should do it as a homework. Okay. This part is similar as the previous question, taking the entire FBD for the entire mass. Only some changes will be there over here. See what those changes are. Solve the question. You will be able to get the answer. Okay. So this is basically your homework question. This is basically your homework question. Where will you put the answer? The answer will be in the comments. The answer should be in the comments. Can you explain block on block friction without Newton's third law and with inertia? Okay. If you talk about, let's say for example, this situation, think this way. This block is moving faster, this block is moving slower. One is moving faster, one is moving slower. So what happens? The one which is moving faster will be slowed down. Correct? The one which is moving faster will be slowed down. That's why the faster moving object will experience a friction in the opposite direction. The one which is slower will be always dragged because of the relative motion. So that's why on the slower one, the friction will be in the front. That's how you can look at it. For the second block, what is the FBD? In which situation? In this situation? In this situation, had you drawn the free body diagram of the second block, I know it is not asked, but chumma, if it is to be drawn just for the sake of it, what will be the forces? One will be normal, one will be obviously mg, there will be also normal from the ground. Friction is in the front, so the reaction force will be backwards like this, no friction below, and this system is definitely accelerating. That's it. The system is definitely accelerating, and there will be also a force here. So for this case, the equation would have been F minus F1 is capital M into A. That would be the equation. F minus F1 will be M into A. Is that okay? Same thing, try to draw the free body diagram for this mass. I'll give you a hint. This force is already there. So you need to think about the friction. You need to think about friction, where will it act? If you are getting confused, then do one thing, draw the free body diagram of the bigger mass, because even the bigger mass is accelerating like this, and there are not many things which are happening in the horizontal direction. So I'm pretty sure you will be able to do it. So I'm pretty sure you will be able to do it, guys. Okay, so think, where will the friction be? If it is here, then it will be here. If it is here, then the friction will be here. So there are only two options. Just figure it out, draw the FBD, write the equations. You will be able to answer the solution, whatever it is, in the comments. Okay, great. So let's go to the next question. Find the frictional force between the two blocks in the given figure. Here the force is not maximum, but they have asked what is the friction between these two blocks. Interesting question. Yes, Alex, let me tell you, always show the forces on the body, not by the body. Never show the forces within the body, always show the forces acting from outside on the body. That is the reason why you will see when I show the forces on the system, not by the system, on it, not by it. And nothing internal also. Nothing internal also. All right. In these type of questions, when they ask you friction, trust me, it is not an easy question. Actually, it's wrong to put it as level 1. It should be level 2 only. Yes. It's very tricky because, number 1, you do not know whether both of them are moving together or there is a relative motion. Because if there is relative motion, the friction will be kinetic, and if there is no relative motion, the friction will be static, and static friction can have many range of values of friction. So I do not even know what is happening in these scenarios. Did you understand the difficulty? If you don't understand the difficulty, then you will not appreciate the problem. You will be like, sir, easy question, sir, something I did, calculation, sir, this is the answer, sir. Okay, next question. No. See, then if small things change, maybe this mu becomes something else, the answer will be different. These masses change, this force changes, the answer will be completely different. The same solution won't work. So that is why you should understand that I do not know whether both are moving together because I am pulling it, or because I am pulling it, maybe this is moving faster, this is moving slower. These are the only two possibilities, yes or no. Got it? Yep. Very good. Weight is also the force by gravity, that is by earth on the box. So it's also an external force. It's on the system, on the mass. So that's why it's an external force. That's why you always show the weight. Make sense? Right. Now, I will assume in these situations, assume something. If it fails, then the other thing will be true. So assume they move together. They move together. There is no harm in it. Let's find out whether they are moving together or not. So if they are moving together, they are going to behave like one single system of 6 kg mass. The force acting on them will be 15 Newton. There will be some acceleration. So force is mass multiplied by acceleration. Therefore, the acceleration will be 15 by 6 divided by 3. It will be 5 by 2 meters per second square. Now, I will show the free body diagram of the upper block to see what is happening exactly over there, which is the 2 kg block. The forces on it are as follows. The weight down, the normal force on it up, it is accelerating forward with an acceleration of 5 by 2 meters per second square. Nothing else is there. That means there must be friction. Who is providing that acceleration? So that friction is providing that acceleration. So I will say, therefore F1 is equal to mass multiplied by acceleration, which is 5 by 2. So the friction will come out to be 5 Newton. The friction will come out to be 5 Newton. Is that clear? So he'll be like, sir, I will mark 5 Newton. No, don't do that. Don't mark friction as 5 Newton, guys. That is wrong. we do not know whether it is correct or wrong. You have to check one thing, and that is Fs max. What is the maximum force? What if this friction which is being demanded is exceeding the Fs max? That means whatever I have assumed is wrong. If this value of 5 Newton is more than the limiting, whatever I have assumed, entire thing is wrong, so don't mark it. So what is Fs max? Mu into n. Mu is 0.3. Normal is mg, which is 2g. 2 into 10. 3 2s are 6. So yes, 0.6. So it will be 6 Newton. Perfect. This 5 Newton is less than 6 Newton. That means it has not yet reached the limiting value. That means this force is not the maximum force with which you can pull this. So there is still some room for increasing the force and to increase the friction. It has not yet reached the limiting value. So hence the friction will be static and it will be 5 Newton. Lot of people, I have seen they mark the answer as 6 Newton by calculating Fs max, mu n. Guys, it is the limit. You have to check actual value. So hence the answer should be 5 Newton, not 6 Newton. Perfect. If by chance, say for example, this was not 6 Newton. Let's say there was another question where, instead of this 0.3, this was example 0.2. This was example 0.2, or let's say 0.1. Then in such a case, what would be the Fs max? What would be the Fs max? Mu into normal. Normal is 2g. So it will be basically 2 Newton. In that problem, what would happen is our friction which is being demanded, which is of 4 Newton, will be more than the limiting value. That means our assumption is wrong. Our assumption is basically wrong. They are not moving together. What was our assumption? They are moving together. Hence, what would be happening is, they have relative motion. What do they have? They have relative motion, which means what you will say is this block versus this block. This block is being pulled. So this block is being pulled faster. This block is just being dragged by the lower block. So the upper block experiences a friction like this. The lower block experiences a friction like this. And this friction is going to be now kinetic in nature. This has to be kinetic in nature. So the kinetic friction is mu into n. Mu is 0.1. Normal force is mg. M is basically 2 and g. So it should be basically 2 Newton force. So in such a case, the answer would have been 2 Newton had you changed the problem. Got it, my dear warriors? How we have to solve the questions? You have to play with the values. You have to think always, what if this happens? What if the value was different? What would happen in that case? So this is how you learn physics. If you just solve the question and go ahead, well, that is not learning physics. Good. I'm so glad this is something which you loved it. So the pseudo force acceleration is equal to the applied force acceleration. What you are asking does not make logical statement. Pseudo force acceleration, what do you mean by pseudo force acceleration? Pseudo force is a force. Applied force acceleration, there is nothing like applied force acceleration. It's the net force which accelerates. Pseudo force is just a force. It does not cause its own individual acceleration. The acceleration used in the pseudo force formula is the acceleration of the observer. I am observing anything, I am accelerating, I will apply pseudo force in the opposite direction, whose value will be mass of that object into my acceleration. That's how it works. Right? Beautiful, beautiful question. I think, yes. This particular question I had given you before. Now there is one more small thing which I would like to talk about also at the same time. and that is basically about something called as the constrained motion, which you might have seen in some problems. Usually these kind of questions are very limited towards JEE mains. I have also conducted a special class on constrained motion. If you just search for it in our here, just search for constrained motion. I have conducted a detailed session for multiple pulleys, multiple constraints, wedge constraints, this constraint, that constraint over here. You can check out that special video, but I'll tell you, mainly there is a trick for solving these questions, which I also explained in that video, but still I'll tell you over here. See, constrained motion means related. Constrained means something which is related, something which is related. If I do, then you have to do. If I don't do this, you don't have to do this. So basically, if then kind of relationships. For example, imagine there is a block here, there is a pulley here, and there is a block here. This is also a constrained motion, because if this block goes down at 2 meters per second, this block has to move at 2 meters per second. This block has to move at 2 meters per second. It is a constrained motion. So all such motions which are related to each other. If this moves, that moves. If that happens, this happens. That is basically called constrained motion. Now what happens is when you get multiple pulleys, meaning something like this. Just look at it. It looks little complex at the start, but once you get the hang of it, it is very, very simple. Just look at this diagram. Let's say I call this as M1. Let's say I call this as M2. Here, there are multiple pulleys. In fact, some of the pulleys are moving. Imagine this mass comes down. It will pull this pulley, which it is attached to, this string, somewhere here. Once this pulley comes here, this mass will also move in the front, but it will not be of the same amount. It is not going to be of the same amount. Or, for example, say like this. Imagine there is a block here. It is being tied over like this from a pulley to another particular block, which can slide over here. If this block M1 moves here, it will pull this block towards the right hand side, and it is right now making an angle theta. But it won't be the same amount. It won't be the same amount. Or say for example, you take this. Looks so complex at the start, but you will see later on it is very simple. This kind of a system, if this moves, the pulley goes down, all the strings will readjust itself and this mass moves up, but it will not be of the same amount. How to solve these kind of questions? Shreyas sir's trick is as follows. First, note down the tensions on the blocks. Note down the tensions on the blocks. For example, on this mass, assume the tension is basically T, because this is the same string which goes here. So the tension should be the same. So on this pulley also it will be T. This will be also T. If T and T is left side, on this string how much will be the tension? 2T. TT will be balanced by 2T. Got it? The same string continues over here. So that's why the tension on this mass will be 2T. Note down all the tensions on individual blocks, and if the tension is not along the direction of the motion, take the component of the tension in the motion direction. Mass 2 is moving horizontal, tension is also horizontal, don't have to split anything. Mass 1 is moving up or down, so tension is also up or down, so don't have to do any components. Just keep it as it is. See the tensions. Here it is T, here it is 2T. The accelerations will be exactly inverse. which means this acceleration, if it is A, this M2's acceleration will be 2A. 1:2, this will be 2:1. Such a simple trick, guys. Did you understand what I just did? Did you understand what I just did? Yeah. This follows from, work done by tension is 0 and all of that. That is the basis of this theory. Fullest Paryong, you will get it, Bacha. There were some issues with the delivery agent. So we are sorting it out. Lot of students have placed a lot of orders. Some orders got mismatched here and there. So that's the reason why the delivery took some time for certain amount of students. So it's being sorted, and probably within a week or two, you should be getting it. Okay. So don't worry. Right. Same thing. Let's apply over here. There is only one string, 100%. There is one tension. Only this is the tension and this is the tension. But what did I tell you? Always check the tension in the direction of the motion. So if M1 is accelerating like this, this tension is in the direction of acceleration. But for this guy, the acceleration, if it is like that, I have to take the component of the tension. Which is the component of the tension? T cos theta for this particular mass number 2. T cos theta in the direction of the motion. Okay, always take the component of the tension in the motion. Now, this is T cos, this is T. So, acceleration will be opposite. If this is A, this will have an acceleration A cos. Cos is to 1, 1 is to cos. Inverse ratio. Same thing also applies for velocity. If the velocity was V, this would have a velocity of V cos theta. Same thing over here also. If this had a velocity of V, this would have a velocity of 2 times V. If this had a displacement of X, this would move 2X. It all has the same ratio. Can you now figure it out for this? What is the ratio, guys? Let's see if you have understood the trick now. And can you apply it to this complex system? Within seconds, you can get it. Will we have another tension for the pulleys? No, that pulleys just change the direction of the tension. It does not add to additional tension unless the pulley has mass, which you will see in rotational motion or rigid body mechanics. Our pulleys are ideal, so they don't alter the value of the tension. They just change the direction of it. So this, guys, just start with some tension over here. The same tension continues. The same tension continues, right? You can see over here too. The same tension will continue. This will be T, this will be T, this will be T, this will be T. So as such, on this mass number 2, what is the tension? T, 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 it is 4T. So 4T, T, that means if this mass has acceleration A, this will have an acceleration 4A. If this has a velocity 4V, this will have a velocity V. So 1:4 is the ratio. Just check it out. Got it? Isn't it simple? Portal gaming, did you understand it now? Yep. Very good. Awesomeness. So this is exactly what your constrained motion problems are. Yeah, all right, most of the times. But I would suggest all of you to check out this particular lecture of multiple pulleys and wedge constraints. Although this is a previous year lecture, but it's a beautiful class with many questions in detail for more problem solving. Okay, so just check this particular lecture out. It is there on this particular channel itself. Great. So with this, we have come to an end of this particular chapter of friction, Newton's laws, non-inertial frames, block on block, and FBDs and different types of forces. Obviously, we will practice more questions and we'll do some practice of 2024 JEE PYQs. So if you are not yet aware, let me remind you that on this channel only, we are also conducting the previous year sessions of 2024. All the questions, January and April, there are lots and lots of them. More than 1,000 questions are there. All those 1,000 plus questions, chapter wise, we are doing the solutions. Okay, we are conducting these sessions where we are solving those problems for all the 3 subjects, physics, chemistry, maths. So make sure you attend it. So Newton's laws is scheduled next. Okay, and some of you, who is it, Abdul, I think you are asking about the course, right? So it's right over here, bacha, let me tell you. So as you are watching this particular class, to enroll into our batch, it's right over here. Just check this out. The Ekalavya batch, this is a mains plus advanced batch. Okay, so this is going to be more focused to push you towards advanced, but if you want a batch which is little bit easy going and then scale you up, okay, then I would suggest you to go for the pro batch. So for that, fill up this form, fill out the form for admission. So we will get in touch with you and you will be enrolled. So you just need to fill up your name, contact number, okay, details. You, even if you are abroad, you can fill out that particular contact number. That is perfectly okay, right? And you can join and enroll into our pro batch. So we have both the batches now for you. Ekalavya batch with rigorous preparation for JEE Advanced. Obviously mains is covered, but you want to start right from very basics and you want to slowly gradually scale up, and after mains you want to prepare for advanced, then you have the pro batch for all of you. Okay, so I hope that helps, Abdul, right? I have pasted the link. Thank you so much. Any other doubt, please put it up in the comments, and I want to see all your likes and attendance in the comments as well as the like button. Okay, thank you. Bye bye. Captain Shreyas signing off. Hasta la vista.